problems on the nth order derivative. If y is equal to 1 by 2x plus 3, then find y10 or y11 or yn. So y is of the type ax plus b. So if y is a 1 divided by ax plus b, then yn is what? Minus 1 raised to n factorial a raised to n, ax plus b raised to n plus 1. So this 1 by twice x plus 3 is of this type. So y is 1 by 2x plus 3. So yn is what? Minus 1 raised to n factorial, like this. A is now 2 raised to n, and ax plus b is 2x plus 3. So 2x plus 3 raised to n plus 1. So this is yn. Now we have to find y10. So substitute n as 10. So minus 1 raised to 10 into 10 factorial, 2 raised to 10 divided by 2x plus 3 raised to 11. The 10 plus 1, that is 11, and that is 2 minus 1 raised to 10. The even power of n is 1, minus 1 is plus 1, and odd power is minus 1. So it is plus 1, minus 1 raised to 10 is plus 1. So 2 raised to 10, right here, 2 raised to 10, it is 2 raised to 10 into 10 factorial divided by 2x plus 3 raised to 11. So this is y10, 2 raised to, right here, 2 raised to 10. Then 2 raised to 11 is same, substitute n as 11. So minus 1 raised to 11 into 11 factorial, 2 raised to 11, twice x plus 3 raised to 11 plus 1 means 12. And so minus 1 raised to 11 is now minus. So minus 2 raised to 11 into 11 factorial divided by 2x plus 3 raised to 12. This is y11. So next problem is y is 2 raised to 3x, then find y12, y13. So if y is a raised to mx, then yn is what? M raised to n, a raised to mx log a bracket raised to m. So y is 2 raised to 3x. So yn is 3 raised to n, like this. M is now 3. So 3 raised to n, a raised to mx, that is 2 raised to 3x. Log a is now 2. So log 2 bracket raised to n. So this is yn. And so y12 is what? Substitute n as 12. So y12 is 3 raised to 12, 2 raised to 3x log 2 bracket raised to 12. Similarly, we have to find y13. Then y13 is substitute n as 13, 3 raised to 30, 2 raised to 3x log 2 bracket raised to 30. So the third problem is y is log sine 4x minus 3. Then find y10, y13. So we know that if y is sine ax plus b, then yn is a raised to n sine ax plus b plus n pi by 2. So this is yn. And therefore y is sine 4x minus 3. So yn is now a is 4. So 4 raised to n sine 4x minus 3 ax plus b means plus n pi by 2. And substitute n as 10. So we get y10 as 4 raised to 10 sine 4x minus 3 plus 10 pi by 2. 10 pi by 2 is 5 pi. So similarly, if you find y13, that is substitute n as 13, 4 raised to 13 sine 4 pi minus 3 plus 13 pi by 2, n as 13. So if y is cos 3x plus 4, then find y9, y10. So write the formula for cos ax plus b. So if y is cos ax plus b, then yn is a raised to n cos ax plus b plus n pi by 2. So by using that formula, find y10, y9, y10. So next problem, this problem is for homework. The next problem, y is e raised to 3x cos 4x minus 5. Then find y10. So y is e raised to ax cos bx plus c. And if this is the formula, then yn is what? Yn is a square plus b square raised to n by 2. E raised to x cos bx plus c plus n tan inverse b by. So this is the formula. If y is e raised to x cos bx plus c, then yn is this. So now y is e raised to 3x cos 4x minus 5. Y is e raised to 3x cos 4x minus 5. So now a is 3, b is 4, and c is minus 5. So substitute, we have a square plus b square. So 3 square plus 4 square. A is 3 and b is 4. Raised to n by 2, e raised to 3x cos 4x minus 5, bx plus c means 4x minus 5, plus n tan inverse B is 4 and A is 3. So we have the answer 3 square 9, 4 square 16, 9 and 16, 25 raised to n by 2, e raised to 3x cos 4x minus 5 plus n tan inverse 4 by 3. Substitute n as 10 because we have to find suppose y 10. So y 10 is what? 25 raised to 10 by 2 means 5 next step, e raised to 3x cos 4x minus 5 plus 10 n substitute n as 10 tan inverse 4 by 2. So this is the answer. Y10 is what? 25 raised to 5 e raised to 3x cos 4x minus 5 plus 10 tan inverse 4 by 2. So similarly, you can find y9. The next problem, y is e raised to 2x sin 2x plus 3. Then find y8. So use the rule y is e raised to ax sin bx plus c. Then yn is what? A square plus b square raised to n by 2 e raised to ax sin bx plus c plus n tan inverse b by. So this is the formula. So now the problem is y is equal to e raised to 2x sin 2x plus 3. That is a is 2 and b is also 2. So yn is what? 2 square plus 2 square. A square plus b square. Raised to n by 2 sin 2x plus 3. Write this term e raised to, write the term e raised to 2x here. It's missing here, e raised to 2x, like this e raised to 2x at this place. Then write sin 2x plus 3 plus n tan inverse 2 by 2, tan inverse b by a, b is 2, a is 2. And then next step is 8, 2 square 4 plus 4 is 8 raised to n by 2. Right here e raised to 2x term, e raised to 2x term there is missing. Sin 2x plus 3 plus n tan inverse 1, 2 by 2, and tan inverse 1 is pi by 4. Next step, pi by 4. Because tan inverse 1 is pi by 4. Because tan pi by 4 is 1. So the answer is what? 8 raised to n by 2, right? E raised to 2x next term, e raised to 2x sin 2x plus 3 plus n pi by 4. And then put n is equal to 8 because we have to find y8. So y8 is what? 8 raised to 8 by 4 e raised to 2x, right? That term missing term, e raised to 2x sin 2x plus 3 plus 8 pi by 4. n is 8, 8 pi by 4. 8 pi by 4 is 2 pi. So 8 raised to 4, 8 by 2 means 8 raised to 4. Right here term e raised to 2x sin 2x plus 3 plus 2 pi. And sin theta plus 2 pi is sin theta. So sin 2x plus 2 pi is sin 2x plus 3 only. So 8 raised to 4 sin 2x plus 3. So y8 is what? Right here term, missing term, that e raised to 2x. So y8 is what? 8 raised to 4 e raised to 2x sin 2x plus 3. So this is final answer. So next problem, find nth derivative of the following functions. So the functions are y is what? X raised to 4 divided by x minus 1 into x minus 2. Y is equal to x square divided by x minus 1 x minus 2. Similarly this problem. So there are 6 problems. Now we'll solve the fourth number problem. Y is equal to x square plus x divided by x cube minus 6x square plus 11x minus 6. So first reduce this function as an addition of partial fractions, sum of partial fractions. So we know the topic, that integration by partial fractions. So we have to reduce this factor in the sum of partial fractions. So what is the procedure? First, factorize the denominator. So what is the factorization of x cube minus 6x square plus 11x minus 6? So this is the synthetic division. By using synthetic division, the coefficient of x cube is 1, the coefficient of x square is minus 6, the coefficient of x is 11, and the constant coefficient is minus 6. So write the coefficient of x square, x cube, x square, x, and constant coefficient. Suppose the term x square is absent in this, then write in the place of minus 6 at 0. Okay, so write the, if the coefficient, suppose 11x is absent, then write 0 at this in place of 11. So write the coefficient of x cube, then x square, then x, and then constant. And then by trial and error method, find here number such that we have the 0 at this place. Suppose try for 1, then if we have 0, then we are through. But if we have non-zero quantity at this place, then try minus 1, then try 2, minus 2, 3, minus 3. So by trial and error method, find a number at this place such that we have 0 at this place. So if you take 1, then for this example we have it is 0. So write 1 as it is. The multiplication of these two is what? 1. 1 into 1 is 1, right at this place. And minus 6 plus 1 becomes minus 5. Then write multiplication of 1 and minus 5 at this place. 1 and minus 5 is minus 5. And then 11 and minus 5 addition is 6. Then this 1 into 6 becomes 6 at this place, and 6 and minus 6 becomes 0. So we have for 1 we have 0 at this place. So the factorization is what? X minus this number. If we have for 0 at this place for minus 1, then first factor is x plus 1. So x minus this number. So now in this problem, x minus 1 is the first factor, x minus this number, into this into x square, this into x square, this factor, x minus 1 as the first factor, then this into x square, minus 5 into x plus 6 as the second factor. And then the factorization of x square minus 5x plus 6 is what? X minus 2, x minus 3, because the multiplication of minus 2 and minus 3 is plus 6, and minus 2 and minus 3 become minus 5. So first factorize the denominator, and then write a by x minus 1 plus b by x minus 2 plus c by x minus 3, then x minus 1, x minus 2, x minus 3 as the LCM, a into x minus 2 into x minus 3, b into x minus 1 into x minus 3 plus c into x minus 1 into x minus 2. Then we have the equation x square plus x plus 1 is equal to a into x minus 2, x minus 3 plus b into x minus 1, x minus 3 plus c into x minus 1, x minus 2. Then put x is equal to the roots of these brackets. So x minus 1 gives the root x is equal to 1, x minus 2 gives the root x is equal to 2, and x minus 3 gives the root x is equal to 3. So substitute the values 1, 2, 3. Okay. So substitute the root of these values, these brackets. So substitute x is equal to 1. We have the LHS is 3. The RHS is what? A. This is 1 minus 2, it becomes minus 1. 1 minus 3 becomes minus 2. And 1 minus 1 is 0. 1 minus 1 is 0. The coefficient of B and C are 0 if we substitute x is equal to 1. Coefficient of B and C are 0. And now we have, this is the plus 2 multiplication, and so A is 3 by 2. Similarly, put x is equal to 2, the second root, the root of the second bracket. So we have the 2 square as 4 plus 2 plus 1, that is 7. And the coefficient of A is now 0, and the coefficient of C is 0. That's 2 minus 2 is 0. And the coefficient of B is non-zero only. So 2 minus 1 is 1, and 2 minus 3 is minus 1. So minus 1 into plus 1 becomes minus 1. So B becomes minus 7. And substitute x is equal to 3. So we have 3 square 9 plus 3 plus 1. And the coefficient of A is now 0. Coefficient of B is 0. Plus 3 minus 3 is 0. And the coefficient of C is 3 minus 1 is 2. And therefore we have C as 13 by 2. And so y is equal to, substitute these values of A, B, C in this step, in this one. So we have y is equal to 3 by 2, value of A is 3 by 2, divided by x minus, value of B is minus 7 divided by x minus 2, and the value of C as 13 by 2 divided by x minus 3. And therefore y is equal to 3 by 2, 1 by x minus 1, minus 7, 1 by x minus 2, the value of this, plus 13 by 2, 1 by x minus 3, 1 by x minus 3. And then yn, this is y now, this is y in the sum of partial fractions. So this is the partial fractions of this factor of y. Then yn, now use the rule, if y is 1 by ax plus b, then yn is what? Minus 1 raised to n, n factorial, a raised to n, ax plus b raised to n plus 1. So now 3 by 2 as it is, and 1 by ax plus b rule. So use the 1 by ax plus b. A is 1 and b is also, b is minus 1. So 1 by ax plus b rule. So minus 1 raised to n this term, n factorial, and a is 1 for this, a is 1 raised to n, x minus 1, ax plus b means x minus 1 raised to n plus 1, minus 7 this constant. Again, the same rule, 1 by ax plus b. A is 1. So minus 1 raised to n factorial 1 raised to n. A is 1 for this problem, 1 by x minus 2. X minus 2 raised to n plus 1, this divided by term, plus 13 by 2. Again, the same rule, 1 by ax plus b. A is 1. So the nth order derivative of 1 by x minus 3 is what? Minus 1 raised to n factorial 1 raised to n, because a is 1, x minus 3 raised to n plus 1. So use this rule. So yn is 3 by 2 minus 1 raised to n. 1 raised to n is 1. So n factorial x minus 1 raised to n minus 1, n plus 1, not n minus 1, n plus 1. Then minus 7 minus 1 raised to n factorial. Again, 1 raised to n is 1, x minus 2 raised to n plus 1, plus 13 by 2 minus 1 raised to n factorial x minus 3 raised to n plus 1. Similarly, the next problem is y is equal to x square plus 4x plus 1 divided by x cube plus 2x square minus x minus 2. Then find yn. So again, we have to convert this factor, y means this factor, as a sum of partial fractions. So first factorize this denominator. So its factorization is x minus 1 into x plus 1 into x plus 2 by using simple division like this. Factorize the denominator and use this procedure, that is divide, write a by first bracket, b by second bracket, c by second bracket, and find the values of a, b, c. And so by applying this procedure, we have these are the partial fractions, sum of partial fractions. So it is converted to 1 by x minus 1 plus 1 by x plus 1 minus 1 by x plus 2. And then write yn. So yn is what? Write 1 by ax plus b rule. So minus 1 raised to n into n factorial into 1 raised to n. Now a is 1, x minus 1 raised to n plus 1. Similarly, the nth order derivative of this function is what? Minus 1 raised to n factorial 1 raised to n, because a is 1, x plus 1 raised to n plus 1. Similarly, minus 1 raised to n factorial x plus 2 raised to n plus 1. And then we have this as the final answer, or take minus 1 raised to n factorial, minus 1 raised to n into n factorial as common. We have this is the bracket. So these are the problems on the nth order derivative. So solve the remaining problems of this type. So if we observe the first problem, so we have to convert this x raised to 4 divided by x minus 1 into x minus 2 as a sum of partial fractions. So for that, consider a, it is equal to, y is equal to, this is equal to a by x minus 1 plus b by x minus 2. And then write x minus 1, x minus 2 as LCM, then a into x minus 2 plus b into x minus 1. And then we have the equation x raised to 4 is equal to a x minus 2 plus b x minus 1. Then find the values of a and b. Then find the conversion partial fractions. Same problem is here. X square divided by x minus 1, x minus 2. Actually, this is its partial fractions are what? Right? 1 plus a by x minus 1 plus b by x minus 2, because the degree of numerator and degree of denominator both are same. So the partial fractions x square divided by x minus 1 into x minus 2, what are the partial fractions? 1 plus a by x minus 1 plus b by x minus 2. So convert that and find the nth order derivative. So the derivative of 1, nth order derivative of 1 is 0. Similarly, the next problem, x by x plus 2 twice x plus 3. So what are the partial fractions? A by x plus 2 plus b by 2x plus 3. And then find the values of a and b. So fourth problem is solved already. Then x plus 1 divided by x square minus 4. So factorize x square minus 4 as x minus 2, x plus 2. And then write the partial fractions as a divided by x minus 2 plus b by x plus 2. 6 number problem, solve this 6 number problem, factorize this denominator, and then obtain the partial fractions and apply the rule 1 by ax plus b. The derivative of 1 by ax plus b is what? Minus 1 raised to n factorial a raised to n ax plus b raised to n. So these are the some problems on the nth order derivative. These are the 9 formulas for nth order. So remember these 9 formulas in order to find the nth order derivative of some standard functions. Okay. So in the next lecture we will see the Lebanese theorem. So what is the use of Lebanese theorem? If you read the statement, if y is equal to u into v, where u and v are functions of x possessing the nth order derivative. So if y is u into v, then yn is this nc0 unv plus nc1 un minus 1 v1 plus nc2 un minus 2 v2 plus data dash ncn uv. What is here? ncr n factorial divided by n minus r factorial into r factorial. So y is u into v, then yn. So this is the rule. Leibniz theorem is the theorem to use the, if you have to find the nth order derivative of the multiplication of two functions, that is y is u into v, then yn. The u into v rule, our 12th u into v rule is the particular case of this theorem. That is, if y is u into v, then y1 is what? U v1 plus v u1 v. Suffix denote the derivative, right? Derivative, okay? U v dash plus v u dash. So that u into v rule of our 12th, that is the first order derivative of u into v, is the particular case of Leibniz theorem. So if y is u into v, that is y is the multiplication of two functions, and if I have to find the nth order derivative of that function u into v, then use the Leibniz theorem. So Leibniz theorem, what is the application of Leibniz theorem? Is used to find the nth order derivative of u into v, the multiplication of two functions, and you have to find the nth order derivative, then we apply the Leibniz theorem. So we'll see the proof of this theorem in the next lecture.